Click the bell icon to get latest videos from Ekeeda.
Hello friends, in previous topics we have studied the different type of configuration along with a load, and that load we always consider as a resistive load, because I have told you many times that load can be any type. It can be a resistive type, it can be RL type. RL type, that means R stands for a resistance and L stands for a inductance, or it can be RLE type. In this video, we are going to see what are these RL type and RLE type load. Are they make any difference if you connect such kind of load to the configuration? That we are going to study in today's video. So now, before we understand these different types of load, till now we have studied resistive load, and we know that if the load is connected as a resistive, purely resistive, then the voltage across that resistive load and the current through that resistive load will be in phase. That means output current and output voltage will always remain in phase if the load is resistive. But what will happen if my load is a resistive inductive, or it is RLE type load? So first we are going to see how this load look like and what will happen if you connect. Now first consider RL load, where R stands for a resistance and L stands for a inductance. You can see in RL type load, resistance and inductor is connected in a series, correct? Now this is heavily inductive load. So basically, when load is a purely resistive, you cannot store energy into that particular load. But if your load is RL type load, you can store the energy. Now, as I said, in a rectifier, you can store the energy, and if you are storing the energy, that particular energy can be fed back to the input AC signal if that particular controlled rectifier will allow it. Now, RL type load is a famous load because it can tend to store energy into that, and this stored energy can be returned back to the AC supply if this rectifier allow. This is the one of the advantage of a RL type. Now, because it is storing the energy, we can use it for a freewheeling. Now, what is freewheeling? If you connect a diode, we have seen in a few configuration when we have studied that if you connect a diode can be used for a freewheeling. Now, if you see here, this is my RL type load. Now, this load is connected to one of the controlled rectifier, which might be changing my AC to DC. Now, one freewheeling diode can be connected in parallel with RL type load. Now, if the RL type load store the energy, due to the stored energy, my diode will become forward bias, and if diode will become forward bias, with the help of a diode, this full energy can be fed back to the AC signal. That is the advantage. Second advantage is that load current, the current which will flow through this load, is a continuous load and it is a ripple free. If the load is a resistive, you will get ripples in your output current. The output current you are getting for the rest of the configurations where we have connected the resistive load, pure resistive load, in that your current might be discontinuous or it can be a ripple. But if you go for a RL type load, your load current is a continuous and it is a ripple free. So if you go for a RL type load, you get two advantages. One is that you can use it for a freewheeling, your energy can be fed back, energy can be stored, and the third advantage is that here your output current will be continuous as well as ripple free. RLE it is a RL type load which is connected with a DC source. Here E stands for a DC source which is connected in a series with a resistor and inductor. Now this type of load is basically used in a DC motor. If you know what is DC motor and how it works, then you always use the load which is a RLE type, where R stands for a resistance of a armature winding. If you have known for a DC motor, it has an armature where the energy is produced. So your resistance is this is the R stands for a resistance of a armature winding. Your L is a inductance, and E is a back EMF or generated EMF. If the current will flow from the device, it generates a EMF, and that EMF stands for a E, or you can say the DC source is connected in series. Again, the advantage of RLE over a pure resistive is that you can store energy in RLE type load. That stored energy can be fed back to the AC source, which is given as an input voltage, correct? Because it is storing the voltage, because it is storing the energy, you can use freewheeling diode in parallel with RLE load. The stored energy in RLE will forward bias this diode, and with the help of this diode, you can feed back the energy to the input signal. Here current can be continuous or discontinuous, that is it depends. Current in the previous RL type mode, we have seen that current was a continuous and it was a ripple free, but here in RLE load, your current might be a continuous current or it can be a discontinuous current. That does depend on the configurations or the circuit which you are connecting with the load. So these are the three different types of load we have studied. One is a pure resistive, that is R type, or it can be RL type, which is purely inductive, or it can be RLE type. So basically in motors we go for a RLE type. In pure rectification purpose, we can go for a resistive type load. But if there is a requirement of a storing energy, then also you can go for a RL type load. So these are the three different types of loads which we have studied in this particular chapter. I hope you understood all the configurations and the significance of a different load, where you can use which type of load. Thank you for watching this video. Stay tuned to Ekeeda. Do subscribe Ekeeda. Thank you so much.